Aloha. So in this problem, we're asked to find the diameter needed for a certain amount of volumetric airflow into a room through an air duct. And we're told that the air duct has a length of 15.5 meters. And we know the volume of the room that the air is flowing into, 8 meters by 14 meters by 4 meters. And the time for this volume to get fully replenished is, we're told, 15 minutes. And the gauge pressure at the incoming side of the air duct, we're told, is 0.710 times 10 to the minus 3 atmospheres. And what we want to know is D, the diameter of this pipe. So we have an air duct coming into a room. And this is also an air duct, so we know that air is the fluid flowing. And to solve this problem, we can use Poiseuille's equation. So you can find this in chapter 10 of the textbooks. Q, which is the volume rate of flow, is equal to pi times the radius of this pipe to the 4th power times the pressure difference over 8 times the length times eta is the viscosity. And because we are talking about air, that means we need the viscosity of air. You can find this in a table in the textbook. So this is another piece of given information. And the units for viscosity are pascals times seconds. And we know that Q is really this volume flow rate. So that's the volume of the room over the time it takes for that room to get replenished with air. And it seems like we don't have information about the pressure difference, P1 minus P2, but we know that change in pressure will be the actual pressure in the air duct minus, on the other side, it's atmospheric pressure. And, P out would be the atmosphere. But this is also just an equation for how we define gauge pressure. So the gauge will read the actual pressure minus the atmospheric pressure. So we can just use the gauge pressure that we're given in this equation. So now we can just rearrange it. We want to solve for the radius ultimately, because we know that the diameter is really just 2 times r. So we're going to use Poiseuille's equation to calculate r from the given variables, and then we can calculate the diameter, which is what we want, by just multiplying that radius by 2. So we can start writing out the equation that we need. Just doing some algebra, we can write this Poiseuille's equation as equation for the radius. I'm just calling P1 minus P2 delta P. And we have to do the 1/4 root. And then we know that to find D, the diameter, is just 2 times r. So it's 2 times this equation. And really the Q, just rewriting it again, because Q is really the volume over time, the volumetric flow rate. So now this is an equation for the diameter, which is what we want in terms of everything that we're given in the problem or that we can look up in a table, like the viscosity. So we can just plug in the numbers and then plug it into the calculator. But we want to make sure that we convert everything to SI units so that we can give an answer in meters, or that all the units will work out correctly. Because remember, a Pascal is a Newton per meter squared, so that's already an SI unit. And this volume is meters cubed. So this is the pressure in atmospheres, and we want to convert this to pascals or newtons per meter squared. That's the same thing. So 1 atmosphere, we have 1.013 times 10 to the 5 pascals. So we have the pressure difference in terms of pascals. And we're told the time is 15 minutes. But we want to write this in seconds so that it cancels out with the seconds up top. So we have in 1 minute, there's 60 seconds. And we have to do the 1/4 root of this part of the equation. So minutes cancel out. The seconds here will cancel out. Pascals cancel out. And we'll have then a meter to the 4th power, and then we're taking the 4th root. So this will be the correct units that we want. And when you plug this into calculator, you should get about 0.94 meters. And that's our final answer for the diameter.